this lesson we will solve a task about reflection, and we will learn how to use Snell's law of reflection. So let's get started. The task is a inflatable raft 4 meters wide and 6 meters long floats on the surface of the water. So here is our float and here is water. The sky is completely covered with clouds that completely scattered sunlight. Determine the depth of the shadow under the raft. Ignore the immersion depth of the raft and the scattering of light. The reflective index of water is taken equal to 4/3. So here is width, length and reflective index of water. Let's get started. Firstly, let's determine the shape of the shadow under the raft. Clouds covering the sky mean that there is no direct source of the light. Thus, when you walk in the street, you won't see your shadow. So if you look there, you won't see your shadow. And the only place you can see your shadow is under your feet. And light beams go from everywhere. From here, from here, from here, from here. This is because there is no direct source of the light. And the last light beam goes along the surface of water here. And in this point he reflects with the water and goes this way. And from this side the same picture. The last light beam goes along the surface of water, and this point he reflects with the water and goes here. So this area is the shadow of the raft under the water. Snell's law of reflection is n1 times sine theta 1 equals to n2 times sine theta 2. n1 is incident index, theta 1 is incident angle, n2 is refracted index, and theta 2 is a reflected angle. In our case, here is an index of air. Here it is, index of air, sine theta 1 is incident angle. In our case, we must draw perpendicular to the surface of water, and incident angle is 90 degrees. This is angle for the last beam here. So it is 90 degrees equals to, here is refracted index, and reflected here is water. So here in this position must be index of water times sine of reflected angle theta. And reflected angle theta is this angle to the perpendicular. Incident index of air is 1. It is always 1. Sine of 90 degrees is also 1. It equals to refracted index of water is 4/3. And here is sine theta 2. So sine of theta 2 is 3/4. we need to find the depth of the shadow of the raft. So let's define it as D, the depth of the shadow. These lines are parallel to each other. This line is parallel to this line. So this angle is also theta 2. And the depth, we have tangent of theta 2. So tangent of theta 2 is, let's call this segment A. So tangent is A divided by D. It means that D is A divided by tangent of theta 2. A is half of the width of the raft. Why do we take half of the width, not half of the length? Because when width is smaller than the length, and only width makes solid shadow in our case, and we need to find the depth of the solid shadow. We have almost solved the task, and the last step is that we must define tangent from sine, and trigonometric formulas will help us. So, as we remember, tangent theta is sine theta divided by cosine theta, but we don't know cosine of theta. And we know that Pythagorean identity is square of the sine plus square of cosine of theta equals to 1. And cosine, square of cosine of theta, is 1 minus square of the sine of theta. So let's substitute sine and cosine. Here is A is half of the width divided by 2, divided by tangent is sine theta divided by cosine. Cosine is square root from 1 minus square of the sine of theta. So let's substitute the numbers. Width is 4 meters. 4 divided by 2 is 2. Divide the sine is 3 over 4. Divided by square root 1 minus 9 over 16. And I have the answer, and the answer is 2 multiplied by square root of 7 and divided by 3. It is almost 1.76 meters. So the depth of the shadow is 1.76 meters. So we just solved the task. Congratulations.